Alright, let's go. Looks like we got a medium today. Number of laser beams in a bank. Anti-theft security devices are activated inside a bank. You're given a 0-index binary string array bank. String array, okay. Representing the floor plan of the bank, which is an M by N 2D matrix. Bank I represents the ith row consisting of the zeros and ones. Okay. Zeros means the cell is empty, ones means the cell has a security device. There is one laser beam between any two security devices if both conditions are met. There's one laser beam. Okay, the two devices are located on two different rows, R1 and R2, where R1 is less than R2. For each row I, where row sub I is less than, row sub 1 is less than I is less than row sub 2. There are no security devices in the ith row. Laser beams are independent, i.e. one beam does not interfere nor join with another. Turn the total number of laser beams in the bank. Wow, this is kind of complicated. Example. What is this? So the laser beams point at each other. Okay, so return the total number of laser beams in the bank. So 0, 1, 1, 0, 0, 1 is zeros. Is there a security device? And 1 is there is. 0 is there isn't a security device. 1 is there is. Between each of the following pairs, there is one beam. In total, there are 8 beams. Oh, interesting. So, so you're counting the number of cells that have beams. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No. Okay. Between there's one beam in total. There are 8 beams. 0, 1 to 2, 1. Oh, it's the number of beams. I see. So 1, 2, 3, 4, 5, 6, 7, 8. There's one beam between any two secure devices if the two devices are on different rows and there are no secure devices on that other row on any row between them. Okay, so secure devices link up to each other on subsequent rows, clearing over any empty rows mostly. So there's no linkage here. Okay, well, that was kind of complicated, but I think, I mean, this seems simple enough unless I'm mistaking something. Okay, so I think what I'm going to do is I'm going to count the number of devices per row. Count the number of devices per row. And then it's just a multiplication of the number of devices on the previous row with the number of devices in the current row, I think. Previous row of where there are devices. Okay. So let's say last count is 0. For every row in the bank, I need to find number of devices on the row, which is the number ones in the string. So I think it's just going to be a counter for every k in row. If k is equal to 1, then increment the counter. And I think I want to do something where I ignore the count if it's 0, right? Because there can't be any connection there. And then if there are values here, then I try to apply it with the previous one. And then I say last count equals count. And then add connections between two non-zeros between last two non-trivial rows. Even though the first row is 0, it's just a dummy row, or the last count is 0. So I think it's just the last count times count, I think, because each thing can connect. So answer plus equals last count times count. I think that might be it. Okay. Oh, interesting. It's kind of really slow, huh? Really slow. I think it has to do something with the way I'm counting the number of ones in the row. I feel like there should be a faster way of doing that. Otherwise it should be parsing it fine. How to find the number of ones in a string, binary string? I wonder if I can convert it to an integer. Convert the string to an integer for every digit in the for every character in the row. For every character in the row. Maybe there's a Python. Let's see. Find number of ones in a binary string Python. That's this. Bit count. Using binary.count. Convert the integer to its binary string representation. So bit count takes the actual number. Integer.bitCount. Wonder like yeah. Binary string dot count parentheses 1 character 1 or convert it to an integer. Which one's faster? Significantly faster, use string.count. Okay, sure. row.count 1. Guess I've never really used that function on strings. Okay. That definitely did speed it up. If count equals 0, I wonder if I should... Maybe I should just do not equals here. I don't think that makes a difference, right? Last count equals 0. Count equals 0. Skip it. That obviously has to be done. Last count times count. That has to be done as well. And then setting the count. Yeah. I wonder if this is random. I'll just run it one more time, see if it's variation of run times. Whatever. I'm done. Alright, summary. So fairly straightforward. Forward solution. Have initial counter variables before for loop. Use for loop to iterate over the row strings. Count the number of devices, which are the ones, using string.count, and then this is the substring that you want to find, or track only the rows that have non-zero devices. So skip if a row has no devices. Row has count of 0. And then for any two consecutive, which is non-skipped rows, the beams that are created is the product of the number of devices in row 1 times number of devices in row 2. Example, row 1 has 3 devices. Actually, let's see, what's the thing? Yeah, 3 devices, the other one has 2. Row 2 has 2 devices, and 3 times 2 equals 6 beams formed. Okay, then keep a running total for your answer. Okay, and then time complexity, this should be O of O. What is the speed here? It's going to be at least O of B. How long is each row? Okay, we're going to use O of mn, where n equals the bank length, n equals the length of row. as the function will need to parse every character to determine the number of devices, which then determines the number of cameras. Base complexity, this should be O of 1, since only counter variables